The CSB's chairman and CEO, Dr. Catherine Lemos, will now begin today's meeting.
Thank you for joining us, and welcome to this virtual meeting of the Chemical Safety and Hazard Identification Board. I call this meeting to order. I'm Catherine Lemos, and I'm honored to serve as the chairman in the CSB and the CEO of the CSB. Today we meet in open session as required by the government in the Sunshine Act, and the board will consider the chemical release of hydrogen sulfide at the Aghorn operating water flood station in Odessa, Texas on October 26, 2019. This toxic chemical release claimed 2 lives, that of an Aghorn employee and a member of the public, through their acute inhalation of the chemical. On behalf of all of us at the CSB, I offer our most sincere condolences to the families that lost their loved ones in this event. Please understand that the reason for our investigation of this tragedy, and thus today's meeting, is to learn from this incident to prevent similar tragedies in the future. In response to the chemical release we discussed today, Odessa Fire Rescue was the first to arrive on scene. A special thanks to those first responders, both paramedics and fully trained firefighters that possessed knowledge and expertise in the dangers of hydrogen sulfide. Fortunately, the chemical release did not claim any other lives, nor was there impact to a nearby residential community. So today we will discuss the incident, the events leading up to the incident and the response, and staff will present the board with pertinent facts and their analysis from the draft report, followed by their proposed findings, probable cause statement, and recommendations. Now, in considering adoption of the report, the board will ask questions of staff to ensure it provides the best opportunity to enhance safety. That is our mission as the CSB. We'll discuss the dangers associated with hydrogen sulfide, or H2S, and how in certain geographic locations, the water flooding process designed to increase production yields H2S as a byproduct. Now, due to the pervasive nature of H2S in the oil-bearing reservoirs in Odessa, Texas, and in many other locations across the Permian Basin, workers and residents alike may be desensitized to the odor. Over 85% of the natural gas produced from the Permian Basin contains a concentration of H2S that is immediately dangerous to life or health. So our review of this event is not just about the unfortunate loss of 2 lives. It is about the nearly 5,000 facilities in Texas alone that produce H2S as a byproduct of the water flooding process that required our careful consideration. The sheer number of facilities that potentially expose workers to the risk of toxic levels of H2S by non-operational detection and alarm systems or other safety gaps warrants our attention, especially when these workers are commissioned to work alone in their daily surveillance of these facilities. For this reason, we'll talk about the detection of H2S, and we'll examine the methods employed by Aghorn to detect and alert for the presence of toxic levels. In broader fashion, we will discuss the importance of design, maintenance, test, and operational procedures in safely operating this type of chemical facility during routine operations and in responding to off-nominal conditions. In addition to detection and alert systems, critical elements for water flooding stations or facilities that involve H2S include the design of both the physical environment and operational procedures to ensure proper ventilation in the event of a release, as well as site security measures to protect the public. We will talk about the importance of safety management programs in addressing myriad risks at chemical facilities, and will examine whether Aghorn adopted a comprehensive and purposeful approach in protecting their workers. We will examine whether they provided their employees with the necessary equipment, information, procedures, training, and management to ensure worker safety. The regulations in place by the Occupational Safety and Health Administration, or OSHA, aimed at protecting workers at chemical facilities will be a part of this conversation. Whether a company is mandated to comply with formal safety management systems, such as OSHA's Process Safety Management or the Environmental Protection Agency's or EPA's Risk Management Program, does not preclude the responsibility to adequately address risks in protecting employees and the public. On that note, we sincerely appreciate the support of our federal, state, and local partners. Odessa Fire Rescue, Ector County Sheriff's Department, the Railroad Commission of Texas, OSHA, and EPA all contributed to this investigation. At this time, I will turn the meeting over to our acting managing director, David Lacerte. Thank you.
Thank you, Chairman. As Dr. Lemos stated, I'm David Lacerte, the Senior Advisor and Executive Counsel, and I'm also the Acting Managing Director of the CSB. Today we will hear from Stephen Kleist, the CSB Executive Director of Investigations and Recommendations, who will introduce our presenter, Lauren Grimm, the investigator in charge of the Aghorn investigation. The IIC and technical staff will give an overview of the incident and introduce areas of investigative focus to include elements of factual analysis in a narrative fashion. After this presentation to the board may then ask questions of the staff on the information therein. Executive Director Kleist will then deliver the findings of the investigation. The board may ask questions about the findings and may or may not participate in discussion for each finding prior to any motion for changes or any motion to accept the findings. Executive Director Kleist will then present any probable cause statements from the investigation with similar rounds of questions or discussion as requested by the board, followed by any potential motions for changes or any motions to accept the probable cause. Finally, Executive Director Kleist will deliver any recommendations from the investigation, followed by another round of questions or discussion as desired by the board. The board will then make any motions for changes or motions to adopt the recommendations. The chairman may then choose a closing statement and or adjourn the meeting. Depending upon the flow of the meeting, we may pause for a brief break at some period. I have reviewed all public comments prior to today's meeting, and I'm confident that today's meeting and the subsequently released final report will satisfy those comments. Any additional questions may be sent to public@csb.gov for consideration and follow-up. The United States Chemical and Hazard Investigation Board is currently operating with a single board member. This so-called quorum of one is provided for in 40 CFR 1600.5A. Under the law, 3 board members constitute a CSB quorum. However, provisions also state that if the number of board members in office are fewer than 3, a quorum shall consist of the number of members in office. Today, that number is 1. As we have a single board member for the duration of today's board meeting, we will suspend parliamentary procedure and all votes from the board shall be considered to be made under unanimous consent. We welcome the opportunity for future board members after they have been nominated by the president and confirmed by our Senate. I want to personally thank the entire investigative team today and note their dedication to their jobs. I'm grateful to be a part of this great team so that we can advance on other investigations and recommendations in furtherance of our missions. I'll now hand it over to Executive Director of Investigations and Recommendations, Steve Kleiss. Stephen?
Thank you, Mr. Lacerte. The Office of Investigations completed the investigation of the accidental release of the hydrogen sulfide gas at the Aghorn operating water flood station in Odessa, Texas, that occurred on October 26th of 2019. The report includes a number of safety issues that were identified by staff during the investigation. Perhaps the most fundamental of these issues was with the lack of an effective safety management program. A safety management program should be an essential element of every organization's business plan. A safety management program provides for the systematic identification of hazards and the development of effective controls of the hazards present or likely to be present. With me today to present the draft report to the board for their consideration to adopt are Supervisory Chemical Incident Investigator Lauren Grimm and Director of Recommendations Charles Barbie. Ms. Grimm assumed the role of investigator in charge of this investigation earlier this year and will be presenting an overview of the incident, the safety issues identified, and the key findings. I wish to acknowledge Wills Hoagland, the original investigator in charge, for his outstanding work and professionalism while serving in this role. While Mr. Hoagland is no longer with the agency, his contributions were the foundation of this incident investigation report. Ms. Grimm, please proceed with your presentation.
Thank you, Director Kleist. I will first give an overview of the process at the Aghorn facility. Aghorn's Foster D water flood station, where the incident occurred, received produced water, which is a byproduct of oil extraction in the area, from approximately 68 crude oil wells in the Permian Basin. The station is used to improve the extraction of oil from underground oil reservoirs. Aghorn operates over 600 producing oil and gas wells in New Mexico and Texas. If you can advance slides, please. Right there. Shown in the figure on the right in this slide, pump jacks extract oil from oil reservoirs and transfer the oil to a tank battery through pipes. At the tank battery, the oil is stored in large tanks where small amounts of water separate from the oil. This water, called produced water, typically contains other components, including hydrogen sulfide, or H2S, which is a toxic gas known to be present in oil and gas reservoirs in the area. After it's separated from the oil, other pipes transfer the produced water from several tank batteries to the Foster D water flood station. The water flood station pumps the produced water back into the oil reservoir. On October 26, 2019, an Aghorn employee called Pumper A responded to a pump oil level alarm at Aghorn's Foster D water flood station in Odessa, Texas. The pump, which is called pump number 1, was located in a building called a pump house. In response to the alarm, Pumper A worked to isolate the pump from the process by closing the pump's discharge valve and its suction valve. Pumper A did not first perform lockout tagout to isolate pump number 1 from its electrical energy sources before performing work on the pump. At some point while Pumper A was in the vicinity of the pump automatically turned on and water containing H2S released from the pump. The investigation team found post-incident that the pump had a broken plunger from which the water and the H2S released. Pumper A was fatally injured from his exposure to the released H2S. Subsequently, the spouse of Pumper A gained access to the water flood station and searched for Pumper A. During her search efforts, she also was exposed to the released H2S, and she also was fatally injured. The investigation team identified the following 6 safety issues in its investigation. It was not the non-use of Pumper A's personal H2S detector, the non-performance of lockout-tagout, confinement of H2S inside the pump house, Aghorn's lack of a safety management program, Aghorn's non-functioning H2S detection and alarm system, and Aghorn's deficient site security. I will now discuss each of these safety issues. Safety issue 1 was the non-use of the personal H2S detector. Aghorn supplied its employees with personal H2S gas detectors to be worn on their person. No personal H2S gas detector, however, was found on Pumper A after the incident. Emergency responders found a personal H2S detector inside Pumper A's work truck. When they removed it from the vehicle, the device was emitting an audible alarm, meaning that the detector had been exposed to elevated levels of H2S. While Aghorn did train its employees in February of 2019 on H2S hazards, Aghorn did not have a formal policy in place requiring its employees to always wear H2S detectors at water flood stations. The staff proposes a recommendation to Aghorn in this area for the board's consideration. Safety issue 2 is the non-performance of lockout-tagout. Post-incident, the incident scene was found with conditions that include the following. Pump number 1 was found running. Produced water was observed spilling out of pump number 1. The power switch for pump number 1 was in the automatic position, meaning that it was configured to be controlled by the PLC. The main power switch for pump number 1 was in the on position. The discharge valve handle for pump number 1 was in a position indicating approximately 95% closed. Advance to the next slide, please. And the position indicator on the suction valve for pump number 1 was about 50% closed. The investigation team determined that Pumper A did not perform lockout-tagout as required by OSHA Regulation 1910.147, called the Control of Hazardous Energy Lockout-Tagout, to de-energize pump number 1 from electrical sources before performing work on the pump. Pumper A closed pump number 1's discharge valve and he partially closed pump number 1's suction valve while the pump was still configured to be automatically operated by the PLC. The PLC's automatic activation of pump number 1 allowed water containing H2S to release from the pump while Pumper A was in the pump's vicinity. At the time of the incident, Aghorn did not have any written lockout-tagout policies or procedures. In interviews, 3 Aghorn employees, including the vice president and 2 production foremen, one of whom had previously been a pumper, they explained to the CSB investigation team that the Aghorn lockout-tagout practice was communicated on the job only. Aghorn did not provide the CSB with sufficient records for the CSB investigators to determine to what extent Pumper A was trained on the verbal lockout-tagout practice. The staff proposes a recommendation for Aghorn in this area for the board's consideration. Safety issue 3 is confinement of H2S inside the pump house. The water flood station pumps were installed inside the pump house. And despite being housed in the pump house, these water flood station pumps could be installed and operated outdoors in an unenclosed environment. And Aghorn also operates another water flood station where a building does not enclose the pumps. The pump house was ventilated by the 2 bay doors on the east side of the pump house. On the night of the incident, these doors were approximately 60% open. The pump house was also equipped with ventilation fans, but the CSB did not have sufficient evidence to determine if these fans were operational at the time of the incident. The open bay doors did not adequately ventilate toxic H2S gas from the building during the incident. Because the failed pump was inside the inadequately ventilated pump house, the released H2S gas was confined within the building, contributing to the high H2S levels to which Pumper A and his spouse were exposed. The staff proposes a recommendation to Aghorn in this area for the board's consideration. Safety issue 4 is the lack of a safety management program. The CSB investigation team requested from Aghorn all written policies and procedures used by Aghorn operating. At the time of the incident, Aghorn's policies and procedures included 1, a cell phone use policy, 2, an alarm call-out procedure, and 3, a pamphlet on H2S hazards. Aghorn had no additional formal company safety policies or procedures. Comprehensive safety management practices include risk identification, assessment, mitigation, and monitoring of design, procedures, maintenance, and training, and they are an essential element of protecting workers and the public from toxic gases at chemical facilities. The lack of a formal company safety policies and procedures likely contributed to the non-performance of lockout tagout and the non-use of Pumper A's personal H2S detector. The staff proposes a recommendation to Aghorn in this area for the board's consideration. Safety issue 5 is the non-functioning H2S detection and alarm system. The Aghorn water flood station was equipped with an H2S detection and alarm system, which Aghorn stated to the CSB investigation team was designed to initiate an alarm when the system detected H2S above a specific concentration. To detect the gas, the water flood station used 8 point detectors, 6 of which were installed around the perimeter of the tanks and buildings, and 2 were installed inside the pump house. When any one or more of these detectors sensed a concentration of H2S gas above a specified level, the system was then designed to send a signal to the control panel in the control room. The control panel would then activate 2 separate alarms. One was an alarm connected to the phone system, which would call the pumper on duty and let them know about the dangerous atmosphere at the facility. And 2, a rotating red light at the top of the pump house to provide a visual cue that there was a dangerous atmosphere at the facility. The alarm system did not incorporate an auditory alarm physically at the facility. CSB investigators asked emergency responders and Aghorn personnel who responded to the incident if they heard or saw any alarms, such as an illuminated light on top of the pump house. None of the emergency responders or Aghorn personnel told the CSB investigators that they saw the light illuminated during the emergency response. The CSB also tested the alarm system after the incident, and the testing found that none of the working detectors communicated with the alarm's control panel, which is located in the control room. Some of the facility's detectors were set to a testing mode, which prevented them from sending an alarm signal, and other sensors that were correctly set up were unable to send a signal to the control room. The CSB also tested whether the beacon light could be functioned had the detection and alarm system been properly configured. And when a test signal from the control panel was sent to the beacon light on top of the building, it did illuminate. The CSB requested from Aghorn all maintenance and calibration records for the H2S detection and alarm system, and Aghorn responded to the CSB stating that it did not locate any responsive documents. Aghorn did not maintain or properly configure its Foster D water flood station facility H2S detection and alarm system. Without the alarm panel receiving any signals from the detectors, neither the beacon light nor the phone system alerted Pumper A to the dangerous atmosphere. The staff proposes a recommendation to Aghorn in this area for the board's consideration. And safety issue 6 was deficient site security. Site security at the facility consists of a gate at the entrance from the public road, a barbed wire fence around the perimeter, and a chain link fence topped with barbed wire around the water flood station. Immediately to the left of the gate, and advance the slide, please. Immediately to the left of the gate of the facility near the public road, there are signs that list several warnings, including warnings about the potential for H2S gas to be present. Additional signs installed to the left of the gate of the interior chain link fence also warn of the potential presence of H2S. Many of the H2S warning signs were corroded. The signs likely were not non-corrosive, they were not reflective, they were not lit, and they were likely difficult to read under low light conditions. Aghorn told the CSB that they expect the water flood station access gates to be locked each day after employees complete their tasks. While employees are present at the facility, the gates are typically left open and unlocked. On the night of the incident, both the gate and the chain link fence were left open since Pumper A was working in the pump house. The unlocked gates allowed Pumper A's spouse to drive up to the water flood station and enter the pump house where she was exposed to toxic H2S gas. Several industry standards issue guidance and requirements for site security at petroleum and petrochemical facilities, two of which include ANSI API Standard 780, Security Risk Assessment Methodology for the petroleum and petrochemical industries, and API RP 781, called Facility Security Plan Methodology for the oil and natural gas industries. The staff proposes a recommendation to Aghorn in this area for the board's consideration. And Chairman, this now concludes the staff presentation on the incident.
Chairman, the board is now available for questions or comments as you deem appropriate.
Thank you so much, Lauren, for the educational and comprehensive overview of the report. This is great. I'm now going to ask some questions, just to clarify some issues. So in the report, it mentions something OSHA refers to as olfactory fatigue that can occur after exposure to high concentrations of H2S or over extended periods. Now, from your understanding, this is a common phenomenon of fatigue, not specific to H2S, correct?
So olfactory fatigue is a condition, I'll say, that can happen with different kinds of gases that have an odor, that over time you may not be able to smell the particular chemical the longer you're exposed to it. H2S is one chemical where people can experience olfactory fatigue. So even if they are in the presence of H2S, they may not know it from the sense of smell because they can't smell it any longer. There are other chemicals that also that condition can arise. It's not specific to H2S, but we know that it does happen with H2S.
So excellent. And to put it in perhaps some layman's terms, I have heard that. So for example, people living in Hershey, Pennsylvania report that they stop smelling chocolate after several months, though visitors report smelling chocolate for up to a distance of 40 miles. And this could be the same type of thing in the sense that you mentioned that when you arrived in Odessa, it was overwhelming to you, but that it may not have been detected by people who live permanently there, correct?
That's correct. Well, I can't comment on if people in the area can smell H2S. I know when we were at the facility, we got whiffs of H2S and we were able to smell it. It has a very low odor threshold, so at low concentrations, if you're not fatigued to the smell, you can detect it.
Got it. So, and we'll talk about this later, but when the response team arrived at the facility, they could even smell it at the entrance of the gate. And therefore, this meant that there were actually really high levels of H2S present, correct?
We can't make the determination on concentration on the smell alone because of the low odor threshold, but we do know that emergency responders did smell H2S, which has a rotten egg odor to it when they arrived at the facility.
Excellent. So for this reason, is that why OSHA warns that the sense of smell should not be relied upon as a detection method for H2S?
Yes.
Excellent. So as described in the report, with any pump failure, Aghorn should have trained employees to be alert to the potential for a release to H2S. Can you tell me more about this?
This facility pumped produced water that came from oil and gas reservoirs at a high pressure. It was about 900 psig. And we know that the water content that goes through this particular facility does have a high concentration of H2S in it. So in the event of an equipment failure, the investigation team determined that it would be good practice for companies to train their employees that that could indicate the release of water containing H2S and to be on the alert of the potential for an H2S release.
Understand. So because of the fact that this terrain in this area, this part of the Permian Basin is likely to have H2S, and the company was aware of it, they trained for it. Any type of pump failure could result, or pump release of fluid could involve then H2S as a component, right?
Yes, that's correct.
Okay.
The H2S is within the produced water.
Okay, thank you. Now, as described in the factual, Aghorn employed two methods to detect and alert for toxic levels of H2S. And I have questions about each of these. One is the facility H2S detection and alarm system, and the other is the personal H2S detector that employees are issued to wear on their persons. So regarding the H2S facility detection and an alarm, how many sensors did the Foster D facility H2S detection and alarm system include, both inside and outside of the facility?
The installed H2S detection and alarm system incorporated 8 separate detectors. There were 6 on the outside of the pump house within the water flood station, and then there were 2 inside of the pump house itself.
Okay. And at the time of the incident, how many of them were in a condition to transmit the detection of H2S to the control room H2S detection and alarm control panel?
What we know is that none of the detectors were actually able to send any kind of signal, alarm signal to the control panel. So in the event of an H2S release, the alarm system would not be able to function an alarm.
Okay, when you say it's not able to function to produce an alarm, you're saying that both alarm or alert mediums associated with this system were not functional. The two that, I'm going to go through those in a second, but neither of them were executed or operational because of the fact that the control panel never received the signals.
Yeah, that's correct. So the control panel, in the event of a release, was not able to get any kind of alarm from the signal communication from the detectors in the field. So therefore, the control panel was not able to respond or trigger either the beacon light on top of the building or the phone call.
Excellent. Okay, so let's assume for a moment that the system was operational and that the control panel received signals from the sensors that reached a threshold. If the system was operational the control panel would have triggered illumination of a rotating red beacon light atop the facility, right?
Yes.
Okay, so was this only visible from the outside of the building?
Yes, the beacon light would have only been visible from the outside because it was on top of the pump house.
Okay, so there would have been no opportunity for a pumper inside the pump house, let's just say, had the event occurred after their arrival. There would have been no opportunity for a pumper inside the pump house to see it?
Yes, that's our understanding.
Okay. And had the system been operational, would the control panel have also triggered a phone call to the pumper on duty?
Yes, that's also our understanding. It triggers both the beacon light and a phone call to the pumper.
So under what conditions would we expect that this phone call could have occurred in the time frame for pumper A to respond successfully? So what assumptions or challenges would be present if it occurred after arrival for them to respond successfully?
We can't know that. There wasn't enough evidence for us to establish in our timeline whether the pump failure itself, which was the shattering of a plunger, happened before or after the pumper arrived at the facility. In the event the primary water loss of containment happened after the pumper was already in the pump house, what we don't know is what the dose of H2S was to the pumper in its first couple of breaths. So that makes a difference in whether someone would actually be able to escape if they received the phone call. With very high doses, becoming unconscious from H2S release can be very quick. If it was a lower dose, it's possible that the pumper may have had enough time to escape, but we don't know that.
Thank you. So can we establish that things such as the cell reception in the facility or surrounding the facility and route the facility, whether or not the pumper has their phone, because we have a phone policy, not sure if the pumper would have had their phone with them. And as we understood from the alert that the pumper received from the system regarding the pump failure or pump anomaly, there was a 5-minute delay from the detection in the controller to the actual phone call. So it's possible that all these things could have played a role. And what I'm trying to get at is the system wasn't functional the day of the incident, and therefore we'll never know if pumper A might have received an alert, correct?
We do know that he did not receive an alert of an H2S release from a phone notification or from the beacon light on top of the building because of the detection and alarm system was not operational.
Thank you. That's helpful. So do you agree that even if operational, this system was not effective in alerting employees, especially if they were inside the pump house when an event occurred?
The way for someone inside the pump house to be alerted of an H2S release is if they had their phone on them, on their person, and they were the person configured in the system that would receive that phone call. If they did not have their phone, or if they were not one of the people configured to receive the phone call, they would not have received a notification of an H2S release.
Got it. And we don't even know if there was a 5-minute delay. A 5-minute delay with a massive or significant release of H2S that could overcome them well prior to the receipt of an alert, correct?
With the delay of notification and the lethality of H2S, that's possible.
Okay.
Again, the main issue here was that the detection system itself was not operational.
Got it. Okay, so can you tell me more about what features would render this type of warning system more effective?
To make the system more effective would be to ensure that the detection and alarm system is operating as it's designed to be operating. And to do that, that requires a dedicated maintenance program, an inspection program by the operating company to make sure they have systems in place to make sure the detection and alarm system is always functioning as it should be. This should be considered a safety critical component of the facility because it's there to protect workers.
And there are, in the in the factual, especially in the analysis, there's guidance on the design of systems that are improvements to this particular one. Absolutely, that this system was functional and working is a basic. What is the guidance on the design of such systems that are available that would provide alerts to those inside the pump house, if it occurred at that moment, or to other non-employees?
For these kind of detection and alarm systems, there's multiple modes that alarms can be communicated to people at the facility, both indoors and outdoors. One is the lights that they had installed. There could also be lights installed the pump house to give the visual cue. And then the second is having an audible component to help alert people at the facility of an alarm.
Thank you. And I know you have recommendations in this area, as you mentioned in your presentation. So now I want to move on to the H2S personal detection devices. To confirm, at the time of the incident, despite the issuance of the personal H2S detectors and their training, did Aghorn actually require that employees wear this personal H2S detector when at the water flood stations?
What we know is that Aghorn did not have a defined written policy or procedure requiring their employees to wear H2S detectors.
Right. And in fact, didn't you learn through interviews that the only method of reinforcement was through informal conversations with employees to encourage its use?
We also know that they did train their employees. They had one of their, when we asked for policies and procedures, one of the items they provided to us was an H2S pamphlet on the hazards. And we also have training records that they did train the employees on H2S hazards. The gap we identified is they didn't have a formal policy requiring wearing H2S detectors, and we were not provided information on the frequency with which they may have reinforced the requirement to wear H2S detectors with their employees.
Yeah, reinforcement seems to be a big issue because especially, I mean, in any company or the safety culture, it's what the management attends to that the employees follow and seem to gravitate towards. So if there was only informal conversation with the employees to encourage its use, that doesn't seem to be a mandate or a requirement, correct?
Yeah, that's correct. Mandates and requirements would more so be documented in a written policy by the company.
Got it, which they didn't have. And finally, do you believe that the training on the personal H2S detectors and H2S in general was consistent with the OSHA warnings that we talked about earlier with regard to olfactory fatigue? Do you believe it was consistent with what we know from guidance from OSHA and NIOSH?
From the training information we received, they did cover levels at which H2S may or may not be detected by the sense of smell. So it appears from what we have, they did cover olfactory fatigue. It appears they also discussed wearing H2S detectors in the training, which the latest one I believe was February of 2019. So it appears that the company did talk about H2S hazards. Really, the gap came back to, was there a policy requiring that employees wear H2S detectors, and was there a system to ensure that employees were following that policy?
So I would venture to say that if a company doesn't require it, and if it only in formal conversations to encourage it, doesn't sound like a wholehearted, doesn't sound like a sanction that we must do this. And this is like, for example, wearing hard hats, wearing safety glasses. You have to go in wearing your H2S detector. And I've been in facilities over the past year where I was issued a personal H2S detector, and that wasn't the main risk at the facility. So when I hear about informal conversations to help encourage, this doesn't make me feel comfortable that the company was serious about the impact that personal H2S detectors could have.
Policy and procedures is the step in the right direction to ensure that employees are following, actually to one established policy, so employees are aware of it. And then there's the component of having a program to ensure that employees are following that policy. Two parts that we see that both of them were lacking here.
Excellent, I agree with you. So now I want to move on to the topic of ventilation. Remind me, what were the 3 potential sources of ventilation in the pump house?
There were 2 bay doors, kind of like large garage doors on the east side of the building. There was some cutouts where ventilation fans were installed on the bottom portion of the west side of the pump house. And then there were just also some vents within the pump house building itself.
And correct me if I'm wrong, but my understanding through the investigation and the draft report, you were able to confirm that the bay doors were likely at least 50% open, if not more, and which was established as common practice. You were unable to confirm whether the fans were operational and in use. And third, there was no mention of whether you were able to confirm if the vents were functional and in use, correct?
So the first responders who were there, we were able to get some video of what the facility looked like when they arrived. And the video does show that the bay doors were about 60% open.
Okay.
The ventilation fans themselves, we don't have any data indicating whether they were operational at the time of the incident. And that was not something we were able to determine as part of the investigation, is if they were actually on at the time of the incident. And as to the vents, they were just kind of natural openings within the building. But what we do know was that the concentration of H2S within the building would have been high enough to cause the fatal injuries during the incident.
Okay, that helps to clarify. So, and I think you helped me lead into the next question, which is, do you have reason to believe that had the bay doors been open, say 60%, but like between 50 and 75%, which is what was indicated as common practice, and with the vents and the fans operational and in use, these three elements would or could have provided sufficient ventilation to mitigate the impact of this chemical release? So do we know, had all of those been operational and we were able to quantify that, are we able to ascertain whether this was sufficient?
No, we cannot ascertain if, had the fans been operational, if they would have been sufficient based on documentation alone, because there was not an official ventilation study performed by Aghorn of basically air changes. If there was an H2S release, how effective would all those ventilation components be in ventilating the building? That would require more robust modeling, which may or may not give us really a true answer to what actually happened on the day of the incident. But going back, we just know at the time of the incident, the building was not sufficiently ventilated.
And that actually answers my next question. Did Aghorn provide you with any assessment or analysis of the effectiveness of their ventilation?
No.
Okay. So would it be fair to say that there's no method to quantify the contribution of the fans or the vents?
Not from documentation alone. That would require some level of modeling.
And I appreciate that. Would it be fair, therefore, to state that Aghorn's ventilation approach, as implemented on the day of the incident, was inadequate, regardless of whether we confirm the status of all three of those elements of ventilation?
Yes, the building was not adequately ventilated to prevent a lethal concentration of H2S inside the building.
Okay. So I will reserve some further comments for later as in respect to findings. Now we'll move on to other parts of ventilation in terms of their procedures. Can we state affirmatively that H2S was a known risk for Aghorn's Foster D water flood station?
Yes, because we know that they had a pamphlet on H2S hazards, and they did train their employees on H2S hazards.
All right. And you've also indicated that Aghorn did not provide you with an assessment or indicate that they assessed the adequacy or effectiveness of the means to ventilate the pump house.
Correct. We did not receive any kind of ventilation study or design documents.
Okay. Now, do you know if the pumps are made specifically to handle H2S, not uniquely, but can they handle H2S?
It's our understanding, yes. I'll say we did not do a detailed design review of the pumps themselves because of the scope of the investigation, but in practice, assuming the pumps are maintained to contain the process equipment, they're capable of pumping the water that contains H2S.
So from what I understand from the manufacturer manuals, there are other H2S and other toxic chemicals could be processed by this type of pump. And there's reason to believe that the pump manufacturer manuals would not have provided specific information to the release of each chemical. I mean, would you agree with that?
The design manuals themselves and determining if the pumps are capable of operating with the process fluid that Aghorn or any chemical facility use. That really falls on the company to make sure they're looking at the design they're selecting and looking at their process conditions and doing an analysis to see if the equipment is suitable for the job. So the determination of pump suitability for the process should be the operator facility's responsibility when designing the process.
That's actually a great segue into my next question. If the manuals don't provide that, which I wouldn't anticipate they would, given the number of chemicals that could be processed by these pumps, how would companies such as Aghorn or their predecessors, since we know that they purchased it from previous companies, how would they have evaluated the design of their facility environment to mitigate the risk of a toxic release?
Facilities can perform what's called a process hazard analysis. So they're looking at the hazards of their process and making sure their equipment can handle those hazards and components of the process. So it's first kind of becoming fully aware of what's called process safety information, of what actually is being pumped through the pumps, what hazards are inherent to those. For example, corrosion, reaction with the material of construction of the pump, for example, and then selecting a pump that can handle the properties of that particular fluid.
And that makes sense. So are there companies that specialize in conducting these type of assessments?
Yes. There's companies out there who can do kind of consulting services, and also the manufacturer a lot of times can provide information on that also.
And to your knowledge, is this a common practice for chemical companies in general, not just water flood stations, but are there companies that do assessments of the design of their facility, not just for the pumps, but the ventilation, to ensure that any mitigation of a potential release is addressed?
I would venture to say that OSHA would say that's a requirement for operating facilities to assess all the hazards of their process, in the event the hazard, that employees are exposed to the hazard, to protect their employees from hazards.
So the next question is, would this type of risk be identified if the company had a safety management program?
A safety management program would be a significant step in the right direction. And what a safety management program is kind of the collection of policies and procedures that a company would use to manage safety at its facility. So ensuring that those procedures are in place, that they're accurate, and that they're being followed would help prevent this kind of incident from happening in the future.
So what you're saying is that safety management programs or best practices would have caught this, but you're saying that companies of all sizes also have the responsibility under OSHA, requirements and regulations to already assess this?
So that, I'll say that depends, answering to my question. OSHA has different regulatory requirements depending on the chemicals and the quantities in the facilities. So chemical facilities that have threshold quantities of certain chemicals fall under the process safety management standard. Companies that don't fall under that threshold quantity requirement just are susceptible to OSHA's other regulatory requirements that aren't specific to the process safety management regulation. But all of their requirements ultimately require employers to protect workers from hazards. And so there are certain OSHA regulations that have specific requirements, for example, lockout, tagout, and their standard on air contaminants. And there's a general duty clause that requires employers to protect workers from hazards.
Okay, so what you're saying is that would fall under the general clause for protection, even if a company does not meet the requirements or the level of production or quantity of chemicals to meet the requirements of the risk management program for EPA or the PSM for OSHA, right?
Right.
Okay. Okay, so now we'll move on to logout, tagout. And the first question I have, because you did a great job of describing what this is, but can you describe for me in the audience today and the audience, right? What does lockout, tagout of a pump mean in layman's terms?
There's OSHA regulation on lockout, tagout, and really the whole purpose is to protect workers who are working on equipment from hazards from that particular piece of equipment. And so what the regulation requires is the isolation of the energy from that piece of equipment. And so there's many different forms of energy. So it's up to the company to identify what are the available sources of energy to isolate the equipment. But that could be electrical energy, that could be hydraulic energy, chemical, thermal, kinetic energy, mechanical, anything potentially that could ultimately cause harm to the worker if they're working on live equipment.
That helps explain and some of my follow-up questions. So you're talking about all sources of energy being associated with a pump are disabled or disengaged.
Correct.
And that includes both, in this case, electrical and hydraulic energy, correct?
Yes.
Okay. And when you say isolating, it's really a term that's synonymous and was in the report. I just want to clarify that.
Yeah, it's just preventing energy sources really from coming in contact with the worker. So, or preventing energy sources from activating the piece of equipment that the worker is working on.
Okay. So in the pump manufacturer manual, a daily lockout tagout of each pump is recommended to include both electrical and hydraulic energy sources. So with that assumption, what would be the benefit to executing lockout tagout procedures on a daily basis?
So the lockout tagout should really be performed prior to workers performing work on equipment. And so ensuring the electrical energy is turned off, isolation valves that allow process fluid to enter the equipment, those are closed. Any residual energy in the equipment is removed. That's the intent of the standard. There's not, to my understanding, a time requirement. It's really just in the event workers are going to be working on equipment.
So the daily lockout tagout was not something that you discovered to be, although recommended by the manufacturer, you did not discover that to be essential.
I can say from our investigation and looking at the evidence, that was not a requirement, and we did not see when such a requirement would be necessary.
All right. I mean, there could be preventative maintenance issues that could be discovered. But in looking over the verbal procedures, you mentioned in the report that it was addressing the electrical energy source. What is the impact of not relieving the hydraulic pressure?
A consequence in this case was that the hydraulic pressure was able to cause water to come out of the pump when there was the pump failure, which was, so that's possible. If it's a really high pressure inside of the equipment and the hydraulic pressure is not relieved, we know this pump generally pumps output pressure of about 900 psig, which is pretty high pressure. So you want to remove anything that could potentially injure employees. And so high pressure conditions, you don't want people working on that or potentially being exposed to that.
And that's right. And we saw that the fact that they even turned off the electrical elements, but then 9 o'clock the next morning, we still have a lot of H2S present. It's related to the suction tank. The vice president of Aghorn is involved. In the factual, do the verbal procedures provided by Aghorn's vice president and 2 company foremen accomplish a complete logout, tagout process as described by the pump manufacturer?
We learned from Aghorn when its personnel arrived at the facility on the night of the incident that the electrical switches were in the on position for this pump number 1. So one of the first steps they took was turning off the electrical supply to pump number 1. That would be a step you would do in a lockout tagout procedure. In this particular incident, since there was a release, they were also working to try to turn off the water supply to the pump. So one thing they did was they isolated the wells that fed this particular water flood station by not having that water come to this water flood station. And then when water was still releasing, they identified there was another isolation valve they needed to close between the suction tank and the valve, which prevented any water at all from getting to the pump. And closing that was able to fully stop the release.
So I think what you're talking about is what the pumper in that moment executed, as well as what was executed over the next 12 plus hours, right? And the fact that they turned off other elements or isolated other elements. Do the procedures that you list, the verbal procedures that you list that were provided to you, do they address both the electrical and the hydraulic sources associated with the pump?
The verbal procedure that we have in the report primarily talks about isolating the electrical sources, which is turning off the main power switch to the pump, as well as turning off the PLC control panel, turning a switch that puts the pump to be automatically activated by the PLC to off. So it's 2 offs in the verbal practice. That was the extent of the verbal procedure we were told in one of our interviews. We were not told anything beyond that.
All right, so it included the electrical, per your factual, it only addressed the electrical energy sources associated with the pump, correct? Not the hydraulic?
In the interview, that's what was told to us. And again, it all goes back to not having the policy and procedure written down. In the interview, it's possible just that portion was told to us because the electrical portion was found on. But in training, if it goes beyond that, we don't have records specifically on lockout tagout training, and we don't know specifically what was communicated to Pumper A.
Got it. So we could state that these verbal procedures were incomplete if what you listed in the factual was the complete list of lockout tagout process. And it didn't include hydraulic, even though we understand that the pumper tried to address that in some form or fashion. The verbal procedures were incomplete.
Yeah, it all comes back to the need to have a written, thought out procedure, because in interviews, where people tell us what they remember at the time, we're not there during the training. So to the extent of what we have in the report, it does only cover the electrical portion of lockout tagout.
All right, so Aghorn submitted post-incident to you, to the team, a lockout tagout procedures. Did they include both of these elements, or did it include only the electrical element?
Post-incident, Aghorn did inform us that they did establish a written lockout tagout policy and procedure. As to the content of that procedure and the full requirements, I would have to go back and review that in the evidence, and I could provide that to you if you'd like.
No problem. So can you confirm for me that the vice president of Aghorn and 2 company foremen, one a previous pumper, as you mentioned, all indicated that the lockout tagout procedures were not written anywhere? This is the focus of this next question, train. They were not written anywhere, and they were trained on the job.
Yeah, so Aghorn did not provide us with a written lockout tagout policy and procedure that they had in place before the incident. So based on that, we know it wasn't a written procedure. There were, some of the workers did communicate that it was on the job training. So yes.
So do you believe that lockout tagout of a pump is considered to be a critical action for pumpers to be familiar with?
Yes, because part of their job is to, in the event of a pump malfunction, to do equipment isolation and preparation for any work that needs to be done on the pump, potentially by a third party. So the pumpers do need to be aware of lockout tagout procedures and requirements.
Are the potential consequences, and I don't mean in every case, but are the potential consequences to the failure to lockout tagout severe and require immediate action?
Say yes. The potential consequences for not following lockout tagout are severe. It can, in this instance, and in many other maintenance instances where any employees are performing work on equipment, there are real hazards associated with equipment, and which can cause fatal injuries. So performing lockout tagout is an essential component to protecting workers.
Essential component to protecting workers. I like how you say that, because that's what I'm trying to get at. From your experience as an investigator across the range of operations in the chemical industry that you have become familiar with, and you've been with our agency, fortunately, for a long time, and we really appreciate your work here. So from your experiences across these industries, is it a normal practice for the company to have only verbal instructions for all work procedures?
Normal is a difficult question. We investigate a lot of types of facilities. They're all required to have a written policy. I'd say it's more typical for us to see the existence of written policies, but sometimes lack of policies is also an issue that we find, and was the instance in this particular incident.
And who requires them to have written policies and procedures?
The requirements themselves come from OSHA and EPA.
Okay.
In this case, primarily OSHA, because this was not subject to the EPA risk management program.
Got it. And I know you point out in the report that Aghorn was not compliant with OSHA's regulations. So how about for critical items? How often do you see that critical safety items don't have any written policies and procedures for their employees?
The how often question is, again, difficult. We come to a facility after they've had a significant incident of some type, and sometimes it is from lack of procedures that we find causal. Sometimes we find it causal from ineffective procedures or procedures that may not have been followed. It's a component or a facet of the investigation that we always look at, but sometimes it happens where procedures are not in place.
Is it rare that a company has absolutely no written procedures for critical safety items?
It's possible. We've seen it before.
So if they had written procedures, and if it was such a essential safety item, as you mentioned, I'll use your terminology, essential safety item, wouldn't you also expect there to be a checklist posted in the control room, close to the controller, that says, this is how one would isolate and conduct a lockout tagout of a pump?
That could be a strategy that companies employ. The way a company decides to, I'll say, enforce its written policies and procedures is really up to the company. That's not necessarily something that's predefined by OSHA of actually how to enforce it. That's a company responsibility, but a checklist is a potential option there.
So that would come into play in the risk assessment and the safety management practices, safety management program, best practices, that you identify the things that are most, that have the most potential to harm employees, and you would address those through mitigations. Whether or not that assessment process is required, they need to do that to meet OSHA regulations to protect employees, correct?
Yeah, it all comes down to having the written policies and procedures, and then ensuring employees are following the written policies and procedures.
Okay. And training plays a role too. If you have written procedures and you don't train and you don't test for currency of how often they accomplish something, you can have written procedures, but do you agree that written procedures alone are insufficient?
Yeah, it's a whole safety management program system. So procedures are one component. And then you can't just stop there. There's a whole nother component that you need to make sure that procedures are kept up to date. You need to make sure people are aware of them through training. And then there needs to be audit programs or what the company will employ to just make sure they're also being followed. So it just takes a lot of attention by company leadership to make sure the safety management program parts are all working together.
I agree. So two more questions on this topic of lockout, tagout, and then we're going to take a short break. In the factual use state that you have notes provided by Aghorn from September of 2019, and this was 2 months prior to the incident. And it indicates that pumper A had previously performed lockout tagout as described, and I'm assuming as described verbally by the Aghorn VP and 2 company foremen, which we have established were likely incomplete. Do the records indicate which steps specifically that the pumper A took?
The notes make it appear that he did isolate the electrical energy. And we're just going off handwritten notes. We don't have a real record of the event. It's notes on a sheet about isolating another piece of equipment. But it does appear in that case that he did isolate electrical energy sources.
All right, so the next question is then a statement based on your response. You were not really able to confirm his knowledge of these procedures and which sources of energy were shut down or isolated, correct?
Yes, and in that case, it's off of a few handwritten notes, but actually confirming what happened, we don't have data or information to actually confirm that, and we don't have specific training records on lockout tagout for pumper A to know to what level he was trained on lockout tagout.
Excellent, and I agree, because I actually read all these documents myself, and from what I understand, pumper A was trained, but we don't know what they were trained to or what the qualifications were for meeting that certification of training, etc.
Yes.
If lockout and tagout was not performed on a routine basis, and especially if the procedure trained were only verbal, they may not have been the complete set of procedures as required by the manufacturer. Do we have any way of knowing whether the pumper or anyone else tasked to conduct lockout tagout of a pump was actually competent to do so?
We are not able to make that determination. It comes back to the need for procedures and following, but whether the competency level of staff, we don't have information to make that determination.
Understand. So if you don't have procedures and you don't have minimum requirements, then you can't qualify.
Correct.
Okay. All right. Mr. Lacerte, I believe this is time for a break. And we have some further
I think it's a good point. I think a normal board process, we might rotate in a rolling quorum here to give the board members a break since we don't have that today. We'll go ahead and take a quick 5 to 10 minute pause. So Brian, the host, can you go ahead and rotate back to the old screen?
I would say 10 minutes so that everybody has, like, pick a number so that everybody has an understanding.
10 minutes, and I'll give a 60-second warning when we're about to come back live. So thank you.
Sir, much appreciated.
All right, I think we're about ready to resume. If operator wants to open things back up. Thank you, and we'll wait for the chairman to join us once again.
My apologies.
All right, and we're back. With the chairman rejoining us, we have regained our quorum and we are ready to proceed.
Excellent. Thank you, Mr. Lacerte. All right, so we have 2 remaining sections to discuss based on the presentation, Lauren, that you have provided. The next topic is site security. Now, I understand that Aghorn had signs posted on the 2 gates or fences as entryways to the facility, and they warned of hydrogen sulfide as a poisonous gas. My question is this: even if the signs were not corroded and were visible from all angles, legible and well lit, do you believe that the average public citizen is familiar with a chemical compound of H2S and aware of the potential dangers associated with it?
As to the average person, potentially no. It could be different in this particular area of Texas, though, where this is an oil and gas town, I'll say, a lot in the area. So the town itself might be more aware.
Yes, and as you mentioned, there was a smell or the odor associated with H2S pervasive in the town. Even with the most obvious signage for those not professionally trained, basically do not enter, maybe even cross and skull bones as we saw on some of the gates. Do you believe this would detract a spouse or loved one of any type from trying to locate their family member?
I can only speak for myself and my experiences, but I would say that just a warning sign probably will not stop a person from trying to find a family member.
Excellent. Okay, so even though the signs were corroded and and you look at them in the report, there are pictures of them. There's a cross and a skull bone. There's a hydrogen sulfide. There's a high electrical component. I'm not sure as a layman, where do I go and where do I not go and how does that affect me, right? So you mentioned guidance materials that API produced regarding site security. What to you are the most relevant elements recommended to this type of facility?
This water flood station is, I'd say, not in the heart of the main town. It's a little bit further out. And it's occupied maybe just a couple hours a day by a single person most days. And so in this kind of facility, I'd say what seems most frequent is just having a gate, a closed gate, potentially a locked gate. And that's the extent of what I've seen primarily. Okay,
but that's the API guidance produces a range of options, correct?
There's API guidance that apply to a wide variety of refineries and petrochemical facilities, going from a refinery to and it could also include this kind of facility, a water flood station. So they do have a range of guidance on site security that the operator can consider when developing a security program.
Great, so there are other options, but at the time of the incident, the gates, not the signs, I'm not saying signs are not important, but the gates were the best line of defense available at the time against the unplanned entry of non-employees that may not be familiar with the chemicals, correct?
Yeah, I would agree with that. A closed gate will generally deter people from entering the facility.
So to confirm, Aghorn's unofficial policy was for employees to leave the gates open when visiting the facility. It doesn't matter how many hours per day, but that was the unofficial policy for when employees were present, correct?
What we were informed was I'll call it a practice. The practice was to close the gates upon leaving. There wasn't specifically communication to us that they require people close it while they're there. It's just they instructed their employees to close it when they left the facility.
Are we having a little technical difficulty here, Brian?
I think we're back up and running.
Gotcha. I know the chairman was booted off the stream there, so let her rejoin and we'll get our quorum back.
I was booted for sure. So we had like the pinwheel, the proverbial pinwheel going. So can everybody hear me and see me?
Loud and
Yes,
clear.
we can.
Excellent. So I'll repeat my last question because I wasn't sure if we covered it or what was heard. So at the time, the gates were the best line of defense available from our knowledge of what Aghorn had installed against an unplanned entry of non-employees. That doesn't mean that there were not other options available, but at the time, what Aghorn had implemented, the best line of defense to prevent the spouse from entering the facility, full access, would have been by closing the gates, correct?
Yes.
Okay. And to confirm, Aghorn's unofficial policy was for employees to leave the gates open when visiting the facility, regardless of how often or what length of time that occurred, correct?
Their practice was that employees closed the gates upon leaving. The practice did not specifically, that we were communicated, did not specifically talk about the practice when they're there, but when they're leaving, they're to close the gates.
Got it. But I believe I read in the factual report that it was common and maybe unofficial policy, unofficial and unwritten policy, was to leave the gates open when you entered because you were there for a certain amount of time and then you came out, right?
It's the pumpers could do that, and it's our understanding from the incident that the gates were likely open when the spouse arrived.
And you collected this information from also other Aghorn employees who said that the common practice was to leave the gates open.
It's our understanding that pumpers did leave the gates open while they were at the facility.
Okay. To your knowledge and experience, and now I'm broadening this to other chemical facilities, is this type of accessibility common at other types of facilities with toxic chemicals present or the potential to release them?
I'd say it depends on what kind of facility you're at. Big major chemical facilities and refineries have very advanced site security. These kind of facilities, these oil and gas facilities that might be more in a remote area that may or may not be occupied very often, will often have less security from what we've seen. It might be a fence or just even signs. And that's I'll say typical from what we've seen.
That they do not have the fences closed?
So if there's a fence there, they can be closed. Some certain facilities that could have H2S may not even have a fence in some cases, but this facility did. And that was the main protection to prevent ingress from members of the public.
So I'll just state that, and we're going to get to this again, but there are almost 5,000 of these H2S producing or yielding water flood stations, which we know come from more or less 60 something oil drilling stations which come to the water facility. There's a lot of opportunity for potentially the public to happen upon a gate that's open, and it concerns me personally that Aghorn was aware of the dangers. They had an interest in protecting the public. And one would think that they would have considered the risks and mitigations. And this speaks to a safety management system or best practices. In my view, this is a major oversight on the part of the company and all other companies that have the potential to release toxic chemicals to the degree that occurred in this event. So let's move on to safety management and talk about safety management programs and practices. So we've already established that Aghorn had no written procedures for a number of things, and I'll just list a couple because we've talked about them. Wearing the personal H2S detector, testing and maintenance of the facility, H2S detection and alarm system. It was not functioning. The pump lockout, tog out process, ventilation of the pump house, and site security. Can you please state again, and I know you mentioned this earlier in your presentation and it's in the report, what written procedures Aghorn did have prior to the incident?
Aghorn had a cell phone use policy. Let me pull this up so I quote the correct ones. They had a cell phone use policy. They had an alarm call out procedure. So that's really what happens if there is an alarm. How does the phone notification system work? They also had a pamphlet on H2S hazards.
And for this type of operation, what type of safety or operational procedures would you expect to see? One of the statements in the report is there were no safety or operational procedures other than what you just mentioned. What other procedures, whether they're safety or operational, would you expect to see? And just name a few, not all of them.
In this case, having a lockout tagout procedure that specifies when employees need to lock out tag out equipment and how to do so, that would need to be in place. Procedures on, or requirements at least on PPE requirements for when operators are at these kind of facilities. Operating procedures on how to operate the equipment at the facility.
Yeah.
Those are examples.
So would these type of procedures depend on whether the company was actually required to submit to formal safety management programs through OSHA or EPA?
So the requirement for a safety management program itself from OSHA more so comes under the process safety management regulation, which Aghorn was not susceptible to. They didn't have the threshold quantity of chemicals. There are other voluntary standards out there on establishing safety management programs, and there's guidance out there, which would be it wouldn't be the requirement, but it would be a best practice for facilities like Aghorn.
So what I'm trying to get at is not the safety management program, but the safety or operational procedures that you just mentioned, lockout, tag out, site security, you name it. Are those dependent on whether or not a company is beholden to OSHA or EPA for a safety management program?
No, because OSHA has separate standalone regulations on lockout, tag out, and air contaminants, which are the ones we specifically talk about in the report, and those apply to everybody.
Great, that's exactly right. They would have been beholden and required to comply with those regulations as you spell out in the report, and they do not. And that has nothing to do with safety management systems or practices, although we could agree that those are encompassed in a risk assessment, safety management system. And Can you repeat for me what you said during your presentation regarding what a safety management program entails?
There are a lot of components on the surface level. It's I guess going back to understanding the hazards of your facility as part one, and then establishing procedures. Some of those are to manage the hazards of your facility. And then there needs to be programs in place to ensure those procedures are kept up to date and that employees are trained on the procedures and that employees are following the procedures. There's other components too, but that's summary of what a safety management program.
No, I know you actually said you did a great job earlier in presenting it. I was just trying to get you to repeat that. But another component is also ensuring that the mitigations they put in place for the identified and prioritized risks would actually be monitored, because what if you put a mitigation in place that was not effective, right? It's a dynamic and living system. And would you agree that this type of system makes good business sense?
Having a robust and effective process safety management program or system in place can help reduce the likelihood of these kind of incidents, and protect employers and protect members of the public. So from a business sense, you have less likelihood of having a major incident and all the significant costs that entails. So yes, from that perspective, there is a business case for having a strong safety management program.
Thank you. And even if it's not required because you don't meet the minimum threshold for complying with OSHA or EPA safety management systems, have you come across other small companies that employ safety management systems and best practices?
The question was, have we come across other companies that employ safety management systems and best practices?
Yes, and I'll just sort of help out here because I'm very familiar with recommendations we make to small companies to employ safety management systems, even though they're not required by EPA and OSHA per the minimum threshold. So I get the question is for you to confirm you've come across other small companies that either employ safety management systems and the best practices in what we just discussed, or we've required it of them, correct?
I know there are small companies out there who do have safety management systems in place. My personal experience is colored by the CSB and our investigations. And a lot of times the facilities, even small companies, have gaps in their safety management programs or a lack of one altogether from what we see. But we don't investigate. I mean, we don't go to every facility. So there are companies out there who do have strong systems in place.
But we do believe that had Aghorn had a safety management program, and I'm not going to say, I say safety management program, and I believe that's in the report for this reason. If they had a safety management program to include best practices of this, which includes risk assessment, prioritization, mitigation, implementation, and monitoring, we believe this is beneficial for all companies, even if it's not mandated by the regulator, correct?
Yes, correct.
Okay. Do you agree that the benefit of written procedures is consistent action across all employees and confirmation of priorities from management?
So that would be the result of a strong safety management program, is you'd have defined procedures. People would be making sure, management really would be making sure the procedures are being followed. And so you would have consistent action from your workers, which would lead to a safer outcome.
Thank you. And final question in this section of our event today. Who was Aghorn's safety officer? I'll ask all these three questions together. When was the last time that they inspected the facility, and what did this involve?
I can't say that I can answer that from information we collected. We don't have the name of an official safety officer or what a role might have been.
All right.
So we don't have information.
So the company did not identify a safety officer across the number of facilities. If I just do the quick math based on the number of drilling operations or drilling sites, we could have maybe up to 9 water flood stations, guessing because I don't know. And so from your understanding, you weren't provided with the name of a safety officer that would have been looking at these types of issues, even if they didn't have a formal safety program, but the safety officer would be required to ensure compliance of the company to, at minimum, OSHA guidelines, correct?
The structure of Aghorn, and if they had a person in the safety officer role, I'd say we don't have sufficient evidence that we've gathered to really opine on the adequacy of it. So we can look further at that if needed.
No, I'm just trying. We don't know if they have one, and if one was not offered, then that tells me enough, right? Typically in investigations, we would interact with a safety officer if they had one. If they didn't have one, one assumption could be that that's why you didn't receive a name. So at this time, I am done with my questioning on the factual analysis section, and I believe it is the time for Director Kleist, David, correct me here, to read the findings.
Correct. Executive Director Kleist, would you go ahead and give the board your presentation on the findings?
Yes, thank you, Mr. Lacerte. The staff developed a total of 33 findings in connection with the investigation of this incident. Weather was not a significant factor in the outcome of this incident. Due to the limitations of the available evidence, the CSB was unable to determine whether the pump failure and loss of containment of the produced water occurred before pumper A arrived at the facility or occurred when the pump energized while pumper A was closing valves to isolate the pump. Due to the limitations of available evidence, the CSB was unable to confirm whether the pump house exhaust fans were operational at the time of the incident. Since the water flood station equipment contained deadly hydrogen sulfide gas, Aghorn should have trained its employees, which should have led to pumper A being aware that an equipment malfunction could indicate a hydrogen sulfide gas release. Pumper A was not wearing his personal hydrogen sulfide detection device upon entering the facility, and there is no evidence that Aghorn management required the use of these devices. Regardless of when the pump failed, had Pumper A been wearing his personal hydrogen sulfide detection device, he could have been alerted of the hydrogen sulfide gas danger and potentially been able to escape prior to succumbing to the toxic gas. All Aghorn facilities where the potential exists to expose workers or non-employees to hydrogen sulfide gas concentrations at or above 10 parts per million would benefit from mandatory use of personal hydrogen sulfide detection devices as an integral part of every employee or visitor personnel protective equipment kit prior to entering the facility. Aghorn did not comply with OSHA Regulation 29 CFR 1910.147, the control of hazardous energy, commonly referred to as lockout tagout procedures, to ensure the equipment was isolated from energy sources prior to performing work on it. Aghorn's lack of a formalized comprehensive lockout-tagout program contributed to Pumper A's failure to de-energize Pump 1 before working on it. Had Pumper A locked out and tagged out Pump number 1 before performing work on it, the significant hydrogen sulfide gas release and fatal outcome of the incident may not have occurred. All Aghorn facilities should have a formalized and comprehensive lockout-tagout program to include policies, procedures, and training to protect workers from energized equipment hazards, such as exposure to hydrogen sulfide gas. Aghorn's pump system could operate outdoors, and at the time of the incident, confinement and inadequate ventilation allowed hydrogen sulfide gas to accumulate to deadly levels inside the pump house. Aghorn did not have sufficient fixtures or facilities to ventilate the pump house, and there is no evidence of Aghorn's assessment of the facility design to ensure proper ventilation. All facilities where the potential exists to expose workers to hydrogen sulfide gas concentrations at or above 10 parts per million would benefit from a comprehensive analysis of the facility design vis-a-vis ventilation and mitigation systems to ensure the workers are not exposed to toxic gas levels. Aghorn did not adhere to the OSHA regulatory requirement 29 CFR 1910.1000 air contaminants to implement administrative or engineering controls to minimize or eliminate the risks to employees being exposed to air contaminants. Aghorn did not employ sound safety management principles in addressing the risks associated with hydrogen sulfide gas at the Foster D water flood station. Aghorn lacked operational, training, testing, and maintenance procedures and records. Comprehensive safety management practices include risk identification, assessment, mitigation, and monitoring of design, procedures, maintenance, and training, and are essential elements of protecting workers and non-employees from toxic gases at chemical plants. At all facilities where the potential exists to expose workers or non-employees to hydrogen sulfide gas concentrations at or above 10 parts per million should be governed by a safety management program that includes a focus on protecting workers and non-employees from toxic hydrogen sulfide gas. Improved communication of the hazards that contributed to this incident, as well as the regulatory requirements to control those hazards, could help prevent future similar incidents. Aghorn did not maintain or properly configure its Foster D water flood station hydrogen sulfide detection and alarm system. Without the alarm panel receiving any signals from the detectors, neither the beacon light nor the phone system alerted Pumper A to dangerous atmosphere. Had Aghorn properly maintained and configured the hydrogen sulfide gas detection and alarm system, and if water produced and hydrogen sulfide released to his arrival, prior to his arrival, Pumper A would have been notified of the presence of toxic levels of hydrogen sulfide gas in and around the pump house. At all locations where the potential exists to expose workers to hydrogen sulfide gas concentrations at or above 10 parts per million, the hydrogen sulfide gas detection and alarm system should be properly maintained and configured, and companies should have a program and process that addresses installation, calibration, inspection, maintenance, training, and routine operations. Aghorn's hydrogen sulfide gas detection and field alarm system was not designed with multiple layers of alerts, leading to the opportunity for a single point failure. Had the chemical release occurred after Pumper A arrived on scene, the one alerting device remaining would only have been the evidence from outside the pump house. Regardless of when water produced and hydrogen sulfide gas was released, had there been multiple layers of alerts in the hydrogen sulfide gas detection and alarm system design at the facility, such as thorough both through the both visual and audible alerts, both internal and external to the pump house, Pumper A would have been warned of pending danger. Even if the field hydrogen sulfide alert system had been tested and operational as designed, it was highly unlikely to have deterred the spouse from entering the facility or provided her with warning of the release of the hazardous chemicals that might threaten her life or those of her children. Audible alarms provide additional warning of toxic gas hazards. All facilities where the potential exists to expose workers or non-employees within the perimeter of the facility to hydrogen sulfide gas concentrations at or above 10 parts per million would benefit from hydrogen sulfide detection and alarm system designs that employ multiple levels of alerts unique to hydrogen sulfide gas, such as with the use of both audible and visual mediums, so that workers and non-employees in all locations would be alerted to a significant release. Pumper A's spouse likely did not see the hydrogen sulfide gas warning signs because they were corroded and she arrived during the night conditions. If she did see the hydrogen sulfide warning signs, she may not have known that she could have been in danger. Aghorn site security did not meet industry guidance and standards to include the ANSI API standard 780, security risk assessment methodology for petroleum and petrochemical industries, and the APR recommended practice 781, facility security plan methodology for oil and natural gas industries. Had Aghorn designed the facility according to these guidelines, the gates would have been secured, preventing Pumper A's spouse from entering the facility. All facilities where the potential exists to expose workers or non-employees to hydrogen sulfide gas concentrations at or above 10 parts per million would benefit from formal, written, site-specific security programs that require employees to lock access gates upon entering and departing the facility. Chairman Lemos, this concludes the staff's findings developed in connection with this investigation. And staff is prepared to answer questions.
Thank you, Steve. And the floor is open for the board to ask any questions for any discussion you may desire.
Yes, thank you so much, Executive Director, Mr. Kleist. One thing I'd like to bring up, which is I do not believe a change in the finding, depending on the position of the staff. So Director Kleist, I'm going to address this to you. Please feel free to have Lauren contribute as well. Across the draft report, this is in the executive summary and the factual, as well as the analysis. There seems to be an inconsistency as to when the pump released the hazardous amount of hydrogen sulfide. So in various portions, I'm going to just quote this here. At some point while Pumper A was in the vicinity of the pump automatically turned on and water containing hydrogen sulfide, a toxic gas, released from the pump. We also have the finding, which I thought was the main message, but it seems inconsistent. Due to the limitations of the available evidence, the CSB was unable to determine whether the pump failure and a loss of containment of the produced water, 1, occurred before Pumper A arrived at the facility, or 2, occurred when the pump energized while Pumper A was closing valves to isolate the pump. And the reason this is important is because in numerous statements it says Pumper A did not execute lockout tagout successfully, and therefore there was a release of hazardous chemicals when we have this exclusionary statement. So Can you please help me to better understand the staff's positioning here regarding when it might happen, when the release, the significant release might have happened? Are these two statements potentially accurate? Meaning, could there have been a pump failure that occurred prior to the pumper's arrival, as well as a secondary release or continued release while the pumper was in the vicinity? So I'm trying to clarify that for myself. Please help me.
Yes, thank you for the question, Chairman. The situation that the staff was faced with is the absence of a significant level of data to be able to make that determination with the highest degree of specificity and certainty. The process control data was virtually non-existent. There was no video surveillance data available that we could examine to determine at one point the major release took place and when it affected the pumper that was engaged in the procedure. What we do know is that there was a high concentration of hydrogen sulfide gas upon the arrival of the emergency response personnel. The employee's spouse succumbed to the high levels of that concentration. So whether there was a residual amount upon his arrival that may have been undetected based on the olfactory fatigue issue that we discussed earlier, or it was the major release took place while the pump was energized, again, getting back to the need to have an appropriate lockout tagout procedure that would enable the pump to be both electrically isolated along with the hydraulic isolation. Again, we noted the positioning of the switches, of the valves to do that. We don't have that level of information to know exactly when it happened, but we do know that there was the release at some point during the time the individual was there. Again, it addresses the overarching findings of the staff, is that having a quality safety management program in place that addresses these risks, starting with the company's assessment of what the risks are, the appropriate mitigation strategies, the appropriate policies in place, along with the safety assurance. Essentially, all of the core elements of a safety management program are in place.
Much appreciated. I understand the limitations to the information we had at the time and from that time till now. My concern is that the way it's written in the report, which the audience does not have access to today, would indicate that it was the pumper's failure to perform the lockout tagout to de-energize it that caused the automatic activation and therefore the release while they were in the vicinity. And if our finding is correct, we don't have to correct a finding if you actually believe what the finding states, which is number 2, due to the limitation of the available evidence, the CSB was unable to determine whether the pump failure and loss of containment of the produced water occurred before pumper A arrived at the facility or occurred when the pump energized while pumper A was closing valves to isolate the pump. Now, the automatic nature of the system could have caused both, but one indicates that it occurred only when the pumper was there, which I find inconsistent with the fact that it could have occurred prior. And if the finding is accurate, what I am requesting of staff is to simply make consistent verbiage that would clarify that it wasn't just in the vicinity, and make it consistent with the findings that you've presented to me.
I can explain that, the phraseology and the appearance of inconsistency. The executive summary says at some point while the pumper was in the vicinity of the pump, the pump turned on and was operating. The reason we know that is because we know the pump was operating at the time the emergency responders arrived at the scene, and we also know the location of where pumper A was found. As to whether pumper A was alert at the time when the pump turned on, we're not specifying in the report, but we know that it did turn on while he was in the pump. What we don't know is when the actual failure occurred. It could have happened before he got there. It could have operated then too, before he arrived there. It could have failed while he was at the facility. But if that needs to be clarified, it can be clarified, but that was the reasoning behind the language in the report. But any feedback on that, I'm very willing to take a look at.
So I actually think in the findings, you accurately describe exactly what you just mentioned. That we don't know. It's possible that the automaticity and the automatic function of the pump occurred prior to the arrival. And as you mentioned in the finding, I believe we need some consistency to clarify that it wasn't only when, as it's not just the executive summary, it's in the factual, it's in the analysis, it's populated throughout the report. I would simply want consistency between the facts to ensure that we are not insinuating that it was, we believe it was only, the relief is only when the pumper was in the vicinity. And it could have been prior, and we can't determine the level of chemical release, right? But if you were to make, if staff was amenable to ensuring the consistency between the uncertainty of when this occurred with the finding, then I have no issue with the finding.
Chairman, if it pleases the board, we can go through the report to identify areas that fit that description that you just presented to us and make the change so that it's consistent throughout the report and it matches the language and the essential message being conveyed in finding number 2.
Thank you so much, Director Kleist. I have one more on this topic, and again, it's about information that leads up to and is stated in safety issues and numerous parts of the report. And the reason this is important to me is because people are going to, have takeaway messages, and it's important they understand what were the critical items. In our discussion earlier and in the findings, we established that the ventilation was not adequate, right? The ventilation as implemented, despite the fact that we don't know whether the fans were operational and to what contribution they could provide, as well as the vents, we do know that there are 2 fatalities, which I take very seriously. And regardless of whatever system or approach was in place at the time, it was not adequate. So I asked questions earlier about, Aghorn's ventilation approach implemented on the day of the incident. Some of the language supporting that, similar to the previous discussion, insinuates this. It's just that the bay doors were not sufficient. We don't know that other things would have been sufficient or not, because all we know is whatever they did was not sufficient on that day. And I would request of staff, if they are open and acceptable to this, to ensure that the verbiage in the the factual and the analysis, to include the executive summary, accommodates what we actually put in the findings and the probable cause and the recommendations.
Again, we'll go through the report sections that apply to finding 12 to ensure that the report language is consistent with that used in finding number 12. The concept here is that the adequacy issue was there a sufficient airflow through the facility that would keep the level to that below 10 parts per million, and a very high capacity ventilation system may actually be able to provide that environment within the facility. In this particular case, we know that it did not because of the outcome of the two casualties. So we believe we were accurate in the way that we described it. However, we will go through the report to ensure that the language used is consistent with the finding.
I appreciate that, because I believe the finding is on target, some of the data, and it may be just to, who knows. I believe the finding is accurate. I just want to make sure that the facts that support the findings are consistent. And if you're amenable to that, I've identified the sections. I'm sure you can find them as well. If you're amenable to that, then that's wonderful. Those are some of the minor revisions in the entire report that we would vote on today. With that, I am done with my questions regarding the findings. We can now move to the probable cause.
Well, I think we need to properly get a vote on that, Mr. Chairman. And I think from what I'm hearing, it sounds like that with unanimous consent, you're approving the findings pending revisions, correct?
So actually, now I'm with unanimous consent. I'm approving these findings as presented. The pending revisions would be in the entire report and some of the supporting information. Got it. That's okay with you?
It works.
Right, you're my process, genie right here. So I believe the findings are accurate. I really strongly believe in the accuracy of them. It's some of the supporting information that we just need to make sure there's no confusion for those people who are going to be reading and digesting this report in the future. So okay. Done with findings. Let's move on to the probable cause statement.
Steve, if you want to present the probable cause statements.
Yes, thank you. Staff proposes the following probable cause in connection with this incident investigation. The CSB determined that the probable cause of this incident was Aghorn's failure to enforce operator use of personal hydrogen sulfide gas detectors when in the vicinity of equipment or facilities with the potential to release hydrogen sulfide, and Aghorn's failure to develop, train on, and enforce lockout-tagout procedures that led to Pumper A performing work on a pump while it was still energized. Contributing to the incident was Aghorn's facility physical and operational design, which did not allow for adequate ventilation of the toxic hydrogen sulfide gas inside the pump house, and Aghorn's deficient safety management program. Likely also contributing to the incident was Aghorn's failure to maintain and properly configure the site hydrogen sulfide gas detection and alarm system. Contributing to the severity of the incident was Aghorn's poor site security that allowed Pumper A's spouse to gain access to the facility.
Thank you, Director Kleist. I'm not sure if I'm here yet. Again, okay, there we go. Just a few questions to clarify, because I think the probable cause statement is on target. The H2S detectors were the first line of defense given the system design at Aghorn at the time. Just a few questions to help clarify for myself and the audience. In terms of a likely contributing to the incident was Aghorn's failure in maintaining and probably configuring the site hydrogen sulfide detection and alarm system. So can you tell me why this is only contributing to the event.
Given the employee's presence within the building, one of the elements of the risk assessment program and their mitigation strategy should have been a use of personal hydrogen sulfide gas detection systems. So if the person was more closely in close proximity of the source emanating the hydrogen sulfide gas hydrogen sulfide, the personal alarm would have worked, allowing the person to remove themselves, again, based on what was put forth earlier, in that if the system was isolated, you would have had a limited amount of hydrogen sulfide gas that could have been released into the air, because you've not only electrically isolated the pump, but you also physically isolated the pump from its inlet and outlet sources. So again, a confined amount of gas. But if it was configured properly, the likely terminology here would be that it could have provided the spouse with the awareness that with the beacon on, something was wrong. And if it took place, if the leak, hydrogen sulfide gas release took place before the person's entry in the facility, even if it was a very small amount, the alarm would have been activated.
So I appreciate that. But what you're saying is if the pumper were already inside, they would not have had this visual alert to attend to. And as through our discourse with Lauren, we understand that there are many complications to whether or not the pumper would receive a timely phone call that would allow them to respond in time. If we have a 5-minute delay from the register to the phone call, that can be significant.
Yes, yes. The awareness and detection concept is perhaps is the best way to describe what took place here. The devices that would have provided the individuals, whether it be the pumper or the spouse or any other individual on site, was a visual alarm located outside facility, so would have provided no meaningful information to the pumper once they're inside the building. And if it were properly maintained and it was properly configured, it would have contained multiple layers of notification, an audible alarm. It would have also contained the visual alarm, so that the person would have been able to be aware that there was a presence of hydrogen sulfide gas above the 10 parts per million. And I'm not, if Lauren has anything to add, please supplement if you have any additional information to share.
No additions.
Thank you both. So I would posit that a person who is not familiar with hydrogen sulfide, maybe if their spouse had mentioned it to them, etc., unless the spouse had mentioned specifically that a rotating beacon light means danger versus we're operating versus all good to go, how would that be contributory? And you've mentioned here that it's likely contributing to the incident, and really we're referring to the pumper. But do you believe that this actually could have deterred the spouse if she had looked, if it was obvious, if it was operating, if she had seen the illuminated light on top of the building?
For the spouse contribution to this incident, if there were illuminated signs, again, going back to the concept of a properly developed system with all of the elements included in the design and functionality of the detection system, and not only would the rotating beacon on the roof have been an indication, but also an illuminated sign that would be activated that would have a message such as "Do not enter," emergency condition. That still may not stop a person from going through, but it provides additional awareness as an element of that notification of a condition that is hazardous once they enter that facility.
Understood. So the reason that isn't a likely is because we don't know that the spouse would have known, and we don't know if the pumper would have seen that prior. So it's likely.
Yes. We don't know the action of what the spouse would have been.
Exactly. Okay. So, Mr. Lacerte, with unanimous consent, I approve this probable cause statement as presented.
Got it. All right, Director Kleist, would you move on to the recommendation section?
Yes, thank you. Staff is proposing 9 recommendations for the board to consider for adoption in connection with the investigation report. The first series of recommendations are to Aghorn Operating. Recommendation R1. For all water flood stations where the potential exists to expose workers or non-employees to hydrogen sulfide concentrations at or above 10 parts per million, mandate the use of personal hydrogen sulfide detection devices as an integral part of every employee or visitor's personal protective equipment PPE kit prior to entering the vicinity of the facility. Ensure detector use is in accordance with manufacturer specifications. Number 2, for all Aghorn facilities, develop a site-specific, formalized, and comprehensive lockout-tagout program to include policies, procedures, and training to protect workers from energized equipment hazards, such as exposure to hydrogen sulfide. Ensure the program meets the requirements outlined in 29 CFR Part 1910.147 and includes energy control procedures, training, and periodic inspections. R3, for all water flood stations where the potential exists to expose workers to hydrogen sulfide concentrations at or above 10 parts per million, commission an independent and comprehensive analysis of each facility design vis-a-vis ventilation and mitigation systems to ensure that in the event of an accidental release, workers are protected from exposure to toxic gas levels. Number 4, for all water flood stations where the potential exists to expose workers or non-employees to hydrogen sulfide gas concentrations at or above 10 parts per million, develop and demonstrate the use of a safety management program that includes a focus on protecting workers and non-employees from hydrogen sulfide. The program should include risk identification, assessment, mitigation, and monitor of design, procedures, maintenance, and training related to hydrogen sulfide. The program must be in compliance with 29 CFR 1910.1000, air contaminants, and 29 CFR 1910.147, the control of hazardous energy, lockout tagout. Number 5, for all water flood stations where the potential exists to expose workers to hydrogen sulfide concentrations at or above 10 parts per million, ensure the hydrogen sulfide detection and alarm systems are properly maintained and configured, and developed site-specific detection and alarm programs and associated procedures based on manufacturer specifications, current codes, standards, industry good practices guidance. The program must address installation, calibration, inspection, maintenance, training, and routine operations. Number 6, for all water flood stations where the potential exists to expose workers or non-employees within the perimeter of the facility to hydrogen sulfide concentrations at or above 10 parts per million, ensure that the hydrogen sulfide detection and alarm system designs employ multiple layers of alerts unique to hydrogen sulfide, such as with the use of both audible and visual mediums, so that workers and non-employees within the perimeter of the facility would be alerted to a significant release. The system design must meet manufacturer specifications, current codes, standards, and industry good industry guidance. And R7, for all water flood stations where the potential exists to expose non-employees to hydrogen sulfide concentrations at or above 10 parts per million. Develop and implement a formal, written, and site-specific security plan to prevent unknown, unplanned entrance of those not employed by Aghorn, starting with the requirement for employees to lock access gates upon entering and departing the facility. Staff is proposing one recommendation to the Occupational Safety and Health Administration, R8. Issue a safety information product, such as a safety bulletin or safety alert, that addresses the requirements for protecting workers from hazardous air contaminants and from hazardous energy. One recommendation to the Railroad Commission of Texas, R9. Develop and send a notice to operators, to oil and gas operators that fall under the jurisdiction of the Railroad Commission of Texas, that describes the safety issues described in this report, including non-use of personal hydrogen sulfide detectors, non-performance of lockout tagout, confinement of hydrogen sulfide inside pump house, lack of a safety management program, non-functioning hydrogen sulfide detection and alarm system, deficient site security. Chairman Lemos, that concludes staff's proposal for recommendations in connection with this investigation.
Thank you, Director Kleist. I do have a few questions regarding the recommendations. We definitely built up support for a lot of the recommendations that are addressed to Aghorn. And so my questions are going to focus in this section on the recommendations that we make to OSHA and the Railroad Commission. My first question is, does OSHA have an existing safety enforcement program or regulations that apply to the safety lapses at Aghorn facility?
For the elements that are covered by OSHA regulations, there is an enforcement program. In communication with the OSHA team, they do have certain constraints with regard to resources, and there's also the issue from a more tactical level that when they do inspections, there's a requirement for them to perform these as unannounced inspections, and given the mode of operation associated with these water flood stations, it's often difficult to find in an unannounced fashion someone that is actually performing work at these locations where they can actually successfully execute a compliance or inspection operation. So again, it is included in their program. However, from a practical standpoint, implementation is a challenge for OSHA.
And that gets at my next question, Director Kleist. Do these OSHA inspections and entail programmed or unprogrammed efforts?
There is a targeted enforcement program that OSHA has, and I'll ask Director Barbie if he would like to provide more information on their targeted enforcement program.
Hi. Yes, Executive Director Kleist. Chairman Lemos, they have national emphasis programs and they have regional emphasis programs, depending upon where they're finding areas of non-compliance or rank things of higher risk, and that's sort of how they set these programs up.
Okay, so I'm trying to understand the takeaway applied to this particular issue. How does your description of programmed and unprogrammed apply to this topic that we've been discussing today and the risks?
Well, in this particular case, they have a regional emphasis program that is looking into the oil and gas components. Now, as far as whether they get all the way downstream into this particular component with the water flood facilities and that kind of thing, there is some question on that. However, at the end of the day, OSHA is responsible for the safety of workers in the workplace. And we have identified safety issues. And so just by jurisdictional requirement, they have oversight of this.
Excellent, thank you. So question, can the OSHA Regional Emphasis Program be used to expand their oversight of water flood stations? That might be a yes or no or an in-between.
It can be expanded. That is absolutely true. However, with expansion comes consequences to the agency that does that. Question being is how many of these facilities are there, and how many additional resources would they need to actually go out and check for these kinds of things? And those are the kinds of pieces of information that only OSHA would have.
Correct. Only OSHA would have, and it's not our responsibility to do their risk assessment or their prioritization for them. They're the ones to determine whether or not this makes sense from a risk perspective, correct?
Yes, ma'am, that is correct.
All right. So we asked them for a safety bulletin. My opinion, this is like the lowest bar we would potentially ask them for. I could ask them for, we could ask them for much more. Why is it important that OSHA take a stand in prioritizing the category, which is a broader scope, right, of hazardous air contaminants from hazardous energy? Why is it important for us for them to establish that is their priority?
Well, they actually have regulations that specifically address them. These are their regulations, and they are the regulator and enforcement body for them. So the strongest message comes from that particular group. Obviously, what we do, we investigate the worst of the worst, and we could put that information out. However, OSHA is the expert, like I said, the regulator, the enforcer. So it has a lot more behind it if it comes from them.
I completely agree with you, Director Barbie. I believe that OSHA coming out with a statement of a priority of this type of potential risk and its implications is the starting point, because then we go down to the Railroad Commission, right? And if the federal OSHA does not prioritize it, then it's going to be very challenging for the local or state entities to do so. So speaking to the Railroad Commission of Texas, why is it that we make that so much more specific than we do the OSHA recommendation for a safety bulletin?
Well, in this particular case, they are talking to and most of these groups are in Texas or relatively close to that. And so they oversee, their jurisdiction is vast. And so because of that, and all the things that we identified, which go beyond the very specific requirements of OSHA, they have the ability to reach out and touch all of these entities much easier.
Do they need the blessing of OSHA?
Oh, they absolutely do not. They're a state agency.
But could they benefit from the blessing of OSHA?
Well, and with regard to worker safety, everybody can. So I would say yes.
Okay, thank you. So does the Railroad Commission of Texas have the ability to implement regulatory oversight over process safety programs at water flooding stations in Texas?
Yes, they do. We have issued recommendations to them in the past to do these kinds of things. And so from a historical standpoint, yes, and they are a state agency. So state regulations are well within their purview.
Okay. And final question here, recommendations appear to focus on increased awareness and process safety notices. If Aghorn had implemented their toxic gas detection and alarm systems and implemented their perimeter security systems effectively, could this have avoided this tragic outcome?
Based on the gaps that we've identified within the investigation, we would say that it is likely, yes.
Okay. So, Mr. Lacerte, I am ready to vote on these recommendations. I believe they are solid and sound. I appreciate staff's dedication to making sure that they are. And I would say with unanimous consent, I approve these recommendations as presented.
Fantastic. I want to thank specifically Chuck and Stephen for their portion of this presentation. And I know we can probably expect the final report to be released shortly, and we can probably expect an animation to follow that for those questions that we've received on that note. Chairman Lemos, the floor is yours for any closing arguments that you would like to give.
Yes, so I believe at this point there is a vote of the report as a whole that is required. So we voted on the initial elements. There are a few changes in the I wouldn't say non-substantive, but they are, we do need a vote to accept the report as a whole before the closing statements.
Yes, I believe it would be proper to accept with unanimous consent the report as a whole pending the revisions as discussed.
Agreed. So with that, with unanimous consent, I approve this report with the minor pending revisions that we've discussed in public domain today, as discussed, and I would anticipate within several weeks we would have this report posted on the website in its final form.
Thank you.
Okay, all right, in closing, first, I want to thank staff for completing this investigation and their diligent preparation for this board meeting. Their professionalism and industry knowledge brings attention to important safety issues for the community. Meeting our mission at the CSB requires the full support of all staff, not just the investigation and recommendation teams, which we heard from today. And I appreciate the efforts of each employee at our agency for the dedication they bring to making every day a productive step towards raising the safety bar across a very diverse chemical industry. And even the most basic of protections for workers in this incident were not reinforced by Aghorn. Training and management, attention to safety issues such as wearing a personal H2S detector is the best and first line of defense in preventing this type of fatality for workers and public alike. Worker safety must be prioritized by especially those companies with employees working in remote locations. And I know this is something we talked with OSHA about. The recommendations that we issued today go a long way to set the example for how companies of all sizes should prioritize the safety of their workers and what they need to do to demonstrate that. So meeting the minimum mark is essential. Going beyond this is a commitment to your employees. Safety management programs are a comprehensive approach to risks at any chemical facility, and we encourage all operators to embrace these principles and best practices, whether this is mandated by any regulatory oversight authority. If our recommendation to OSHA is implemented, this would send a very strong message to the chemical industry of their priority to protect workers from the risks of chemical releases such as those experienced in this incident. This statement would not be limited to hydrogen sulfide, but would encompass workers across the facility domains in the chemical industry. If our recommendation to the Railroad Commission is implemented, this would make significant strides to educating the chemical industry involved in extracting natural gas and address the majority of water flood stations that involve H2S. Now, many of these companies are small, and this recommendation will go a long way to help educate those companies that may not be on the leading edge of safety at this time. Now, as I mentioned in the opening of this meeting, the impact of our investigation to the Aghorn event is not just about unfortunate circumstance that occurred to 2 lives and their families and extended families. Albeit tragic, this is a call to action for all companies, large and small, to step up to the plate to prioritize the safety of your workers and your community. With this, we stand adjourned.
Thank you. And as a reminder to all CSB staff, go ahead and close out and close your windows, and talk to you soon.
Thank you, David.